Hello, this is Module 2D. So we've gone over the matplotlib basics, and now that we've done that, I want to show you just a few more kind of special graphs that are really going to help when you want to explore kind of a full data set. So for this, we're importing in a new data set. It's called the Boston Housing data set. This is where I grabbed it from. It's a really well-known data set, and these are some of the variables it has in it. It has things like crime, capita per rate. It has things like the average number of rooms per dwelling, tax information, and kind of I shouldn't say the purpose of this data set, but what people often try to do with it is predict the median value of owner-occupied homes is kind of what people try to do here. So I'm going to show you a few graphs that are going to be really, really useful when we get to modeling as far as just getting a look at this whole data set. So first of all, let's read it in. And then the first thing I want to show you is kind of some special syntax, which is going to print histograms for all of the columns in the data frames. So this isn't quite the syntax that we've been using with our general matplotlib. You can see it's kind of more of a method, but I just want to show it to you because it's really great for kind of, instantly printing out histograms for everything. So with this, you can really quickly look at the distribution of your data. Another thing that's going to be useful when you get to modeling is looking at correlation. So what this code right here does is, first of all, we create a correlation matrix, and we do that just by using .core. It's a method. And so if we just run this, it's going to just print out a matrix right here. Oh, and then I guess I would actually have to, return it. So what each of these boxes are, it's the Pearson correlation coefficient, which is a correlation coefficient. It's looking for linear correlations. And kind of how you read it is you'd go back here and you say, okay, crim, and you come down to age, and cool, the correlation between crim and age is 0.35. So how correlation coefficients work is a 1 would be a perfect positive correlation. So that would be like the relationship between inches and feet. There's a perfectly positive and linear correlation between inches and feet. If you have 12 inches, you have 1 foot. If you have 24 inches, you have 2 feet. That is what a perfectly positive, that is what a perfect correlation of 1 would be. If your correlation coefficient is -1, that means you have a perfect negative correlation. So -1 is just as strong as 1. It's just in a different direction. So something that makes something else go down when it goes up. And then if you have a 0, that means that there's like no correlation at all. They're just completely unrelated. So that's what the .core function does. And this you can look at. You can go look at the values, but just another line of code that makes it a lot more useful is using this background gradient, and then surprise is already given away. I already ran this chunk, but it shades it. So now our dark reds are strong positive correlations, our dark blues are strong negative correlations, and of course here in the middle, that's just showing things correlations with themselves. So I mentioned that usually when people look at this data set, they're interested in the MED-V. And so you can look down here and you can see how well each variable is correlated to MED-V. Pretty cool. One last thing that you might want to do is print out multiple scatter plots at a time. So if we're interested in MED-V, this tells us what the correlation coefficient is, but we might still want to actually be able to visualize that correlation. And how we can do that is we can go ahead and plot our, the medv as a function of each of these variables. Because eventually, if we build a model, that's pretty much what we'll be doing, is we'll be plotting medv as a function of these variables. So that's what this function right here does. So we talked about using subplot. So let's see, I'm going to add another line right here. What I'm doing up right here, I'm just setting an index equal to 1. I'm also changing my figure size just to make sure things don't come out too tiny. And then I've got this loop. So for column in my housing columns, if the column is equal to medv, then I'm going to skip over it because that's what I'm plotting against. But if it's not, then, well, first of all, I'm going to identify what subplot I'm on. Then I'm going to build my scatter plot. Then I'm going to add a title to my scatter plot. I'm going to call it whatever that column name was. I'm going to add my X label and my Y label and increment X, which, as you saw, I was just using that to keep track of which subplot I'm on. And actually, as I was going through here, I realized that this isn't quite what I wanted. I want to have housing as my response variable. So it should be right there. And I mean, it's going to let me see what the relationship is either way, but I think this is how I have my axes labeled. Okay, so now whatever is in my column is my X. Okay, I should change these two. So yeah, whatever is in the column I'm on, that's my X, and medv is always my Y. So we're going to go ahead and run this. And there we go. It shows how medv is related to each one of these variables. So some of these relationships look kind of random. Some of them look really, really nice and linear, like that right there. That's a nice linear relationship. It might be about the only one. That one's decently linear. But yeah, so these are just a few kind of specific routines, I guess you can run, that can be really useful when you're looking at a new data set and specifically getting ready to model it. So you can come back and watch module 3, and that's when we'll get into modeling with linear regression.